Later on in this video, we'll discuss the breakout trading strategy on gold against dollar, also known as XAU-USD. We'll start with the basics on what makes this strategy the way it is. We'll then see real-life examples and perform some technical analysis in the MetaTrader 5 desktop application. Then after that, we will implement a trading strategy using Python programming language. Then we'll perform a backtest on that particular trading strategy for 3 years straight and observe the outcome. This tutorial is aimed at helping you gain an understanding on how you can create Python-based trading robots that work with the MetaTrader 5 platform and how you can backtest and optimize your systems with less hassle. So make sure you stick right to the end where we'll uncover the secrets of this trading system and help you beat the market. Now, before we proceed, I just want to let you know that this video has been taken from a broader course that's available on Udemy, which covers each and everything related to algorithmic trading using Python and the MetaTrader 5 platform. So if at some point you find yourself wanting to understand the concept discussed in this tutorial in detail, or you find gaps in your knowledge, there's a link in the description for the full 6-hour course of content available on Udemy. Also, don't forget to like and subscribe if you found this video useful. We plan on releasing more contents like this, so if this is something you want to learn, make sure you subscribe and turn on notification. This way you get notified once we release new content on a weekly basis. Now, this tutorial assumes that you have a basic understanding of the Python programming language. You have the MetaTrader 5 desktop application installed in your Windows machine, and you have a basic understanding of forex markets and trading in general. All the code files and examples discussed throughout this tutorial will be linked down in the description below. So, without further ado, let's jump into the video. According to investopedia.com, a breakout strategy is a strategy that involves entering a position when a stock or asset moves beyond the defined support or resistance level, signaling the potential start of a strong price trend. This approach is significant because it can capture major price moves and periods of increased volatility when executed correctly. Successful breakout traders rely on identifying key price levels, planning precise entry and exit points, and managing emotions to stay disciplined throughout the trade. For those unfamiliar with the breakout strategy, this is what such strategies look like. You have a defined resistance and a support line. We expect that when the market breaks above the support line, that is a bullish signal. If it does the opposite, we could say that is a strong bearish signal. Now, the key with such strategies is identifying these support and resistance lines. So let's go to MetaTrader 5 and understand this in detail. Let's close the trade section. So this is a chart we had last time, so remove this 200 moving average indicator, right clicking on the chart and going to indicator list, remove it, and let's try to perform some manual technical analysis. So say this is your defined support line. It doesn't have to be perfect. Let me pick up this equidistant distance channel. And then I'm gonna draw the two support and resistance lines, one at the top and the other one at the bottom. It doesn't have to be perfect. The one at the top is the resistance line and the one below is the support line. If you are at this time period in the market, then you could say this is a large candle which could indicate an increased volatility that signified a long signal. So if you are at this point in the market, you were supposed to open a buy trade. Now, that is the breakout strategy in its simplest form. Now, when trading breakouts, it's important to consider the underlying support and resistance levels. The more times a stock price has touched these areas, the more valid these levels are and the more important they become. At the same time, the longer these support and resistance lines have been in play, the better the outcome when the stock price finally breaks out. So when using this breakout strategy, you should look for where the price consolidates or the market is in ranging for an extended period of time. Now, without putting enough thought, the breakout strategy can become one of the most complicated and challenging strategies to code. The reason is simple. Such strategies were made for manual traders. And if you try to write the conditions for a breakout strategies from a manual trading perspective, things are going to be difficult because this relies on pattern identification, something humans excel at. Not to mention that sometimes these patterns can be subjective. Depending on how you look at it, the same pattern can look different to another person, or can look different coming from a different perspective. Let's see, for example, one can say this is supposed to be here. Let's zoom in a little bit, and you could say the resistance should be this line, while at the same time you might disagree and say the support should be here and the resistance should be here. Let's delete the old trend line. Okay, you could say this should be the support line. Like this place. All looks good and valid. So this goes on to show that the breakout strategy is complicated if you try to approach it from a manual trading perspective. Now, algorithmic traders, when coding these breakout strategies, often rely on the Bollinger Band indicator. To understand this, let's attach the Bollinger Band indicator to the chart. Go to Insert, and under Indicators, you want to go to Trend and find the Bollinger Band indicator. Just keep everything to default, and for the color I prefer Dodger Blue. Here it is. I'm gonna press OK. Let's increase the line dimensions for each band, make it wider. There you go. So this is how the Bollinger Band indicator looks like. So algorithmic traders write their logic that when a candlestick closes outside this upper band, that is a bullish signal. This indicates the breakout. And if it does the opposite by closing below the lower band, that is a bearish signal. These patterns can be observed in different places, and they are not perfect, just like any trading strategy, but it's a good starting point when trying to write for the breakout strategy. Here we had a nice signal and the market went bullish. We had some other signals in different places. As you can see here, the market was ranging. It doesn't have to be perfect, and this is the good thing about the Bollinger Band. Unlike trying to draw the perfect lines in the market and hope to see the breakout happen in the most appealing way, something which doesn't happen in the market. So this is a rough estimate of the breakouts and one of the simplest way to catch a breakout in the market. However, in the previous chapter, we discussed a trading strategy based on technical indicators. This time, let's try something different. So rather than using the Bollinger Band, let's remove it. We're going to create a simple trading logic in such that if the current price exceeds the maximum price in a day or the minimum price that occurred in a certain days or a certain number of bars we're going to specify in the script, then we could say that it's either a bullish breakout for the maximum price or a bearish breakout for the minimum price in a given window. This simple logic should give us the simplest way to catch these breakouts from trading instrument. So let's dive in our text editor and implement this simple breakout strategy. Now, from your project's root, create a new file. Let's give it the name breakout strategy. With the file created, let's import the necessary modules. So we need the MetaTrader 5 API. We also need the pandas module, as well as the NumPy module for mathematics calculations. So the first thing we need to do in the script is to initialize the MetaTrader 5 instance. Then we can display an error. Then let's define an instrument and the time frame we need. This time let's trade on XAU-USD, which I think is the perfect instrument for this breakout strategy. This is gold against dollar labeled as XAU-USD. Then we could say time frame and select the 1 hour time frame. So from the MetaTrader 5 API, get the constant code timeframe_H1. We also need the magic number for our trading robot. Let's give it the value 2026. Then the slippage, set it to 100. Then we have to instantiate the ctrade class and we forgot to import it. We should go from strategy tester 5, get the trade class submodule. From there, get trade, import the ctrade class. So define a variable called m_trade and assign this ctrade class. It expects the magic number. Filling type by symbol. Give the symbol we want to work with. It also expects deviation points, also known as slippage. We'll give it as well. And last but not least, it expects the MetaTrader 5 instance, the initialized one. With the ctrade class instantiated, let's define some utility functions we're gonna need later on. We need the function to check if a position exists, similar to what we did in the trend following example. So let's go from there and copy the code we used for detecting if a position exists. Paste it down here. Then let's define the main function. This is when all the trading actions will take place. Then from the main method, let's define the rates data frame. This time we do not want to repeat the same mistake which made our program slower. So we have to introduce the new bar event handler or the function to check if a new bar has triggered If that happens, we have to collect bars from method 5. Now, this method depends on the function called period seconds, which is available in the strategy tester module and the MQ5 submodule functions. From there, extract the method called period seconds. We need some global variables. As I described earlier, our trading strategy is when current price exceeds the maximum or the highest value that occurred in a day or a given window, that is a breakout. And if it happens otherwise, the current price is smaller than the lowest price in a given window, that is a bearish signal. So let's define the window, give it the value of 24. We also need the shift value, because if we check blindly what happened in the past 24 candles, which include the current candle, the shift value is there to avoid including the latest value in the market when detecting the extreme points in the market, which include the highest price or the lowest price. This is because the current value can become higher than the highest price. Then the logic becomes false because the highest price becomes the new extreme. The same applies to the lowest price. So we should define it as shift, give it the value of 2. Let's define the rates data frame as well. This should be a global variable. Let's set it to the value of none. Then from inside, we can refer to the global rates data frame object. From the method.5 API, get this latest tick by using the method symbol _info_tick. We should check if ticks is none, return to prevent further execution. To collect the rates or to get the latest bars information from the market, we should check this under a new bar. Only if a new bar has emerged is when we want to get bar information from the terminal. So we check if is_new_bar. For the time frame, we give it the value of time frame. For the current time in seconds, we give it the value of time from the ticks object. Only if a new bar has emerged is when we want to get the rates from the terminal. So for method.5 API, use the method copy rates from POS to get the bars information. For the symbol, we specify an instrument and the time frame, as well as a starting position. We set it to 0 to get from the current bar. Then with the rates object, which is a structured NumPy array, we can convert it to a pandas data frame. We assign the rates object. Then we could check if rates is none, meaning the process of getting rates from the terminal was a failure, or we could measure if the length of the rates returned is less than the value we anticipated. And return to prevent further execution. This is rates_df. Then we need to get the close price. Now to get the close price, let's define a variable called current close. This will give us the value we can compare with the rest of the values in the window to see if the current close is above or below the extreme values from a given window. Then we can go from the rates data frame, get the close column, Now to get the support and resistance lines, let's define the variables. We can say support line. Then from the rates data frame object, before that we should define the rates object. Let's give it the value of rates underscore window. Then from the rates data frame, we are going to get each and everything except the last values specified by the shift variable. This means that we collected 24 bars candlesticks from the last 1 hour candles. Then we isolate the final two values, which is the latest bar and the one prior to that. After this isolation, the remaining values are the ones we are going to use for detecting extreme values, the highest high and the lowest low. By having the shift value, we're explicitly avoiding the final two bars for Windows calculation. This way we can avoid using the latest price, which could be the new extreme. Now with the rates window, we want to obtain the support and resistance lines. We could use the NumPy module, get the maximum price from this rates window. This is support line, so we should get the minimum value from this rates window, a column called low. So we get the lowest low. Then for the resistance line, we get the maximum value from the highest values in the window. Then we could say if the current close is greater than the resistance line, also known as bullish breakout, this is a long signal, signifies the market is going upward. And if the current close is below the support line, this signifies the bearish breakout. The market is going down. However, if we refer to the definition of a breakout strategy discussed earlier, this approach is significant because it can capture major price moves and periods of increased volatility. So, volatility is one of the key features of this breakout strategy. So, if possible, you could also check if there's an increased volume as a confirmation signal before you can decide whether you want to open a trade in either direction, because the condition we just defined in our Python script is a simple one. This happens all the time. The price can go up and exceed the highest high or the previous lowest low. So, let's introduce a confirmation signal that relies on volume. Now, when it comes to volume, volume is difficult to obtain. It's impossible to get the volume data from the Forex markets. But the MT25 terminal, from its rates object, it provides something called tick volume. We could use that as a placeholder for volume and check if during the breakout there was a period of increased volatility. Define variable latest underscore tick underscore volume. Then from the rates data frame, we could get the tick volume column. Let's obtain the final row from the tick volume column. Then calculate or obtain the mean of the tick volumes. So we could say mean tick volume. This time we go to the rates window and get the tick volume column. Once the object is obtained, we calculate the mean of tick volumes from the rates window. Now that we have the latest tick volume and the mean tick volume, we could check if the current tick volume exceeds the mean of tick volumes. If that occurs, then we could say that is an increased volatility, which signifies the breakouts. So the breakout makes a lot more sense. Create an if statement before these two statements. We could say if latest tick volume is greater than the mean volume, then append this to the right. For a bullish breakout, we should open a buy trade. Then we could go to the mtrade object and call the method buy. It expects the typical values such as volume. Let's define the volume value. We can say volume. Let's go big this time. Place it at 0.1. Assign the volume value. Put a comma, and another thing expected from this is the symbol instrument you want to work with. It also expects the price. Now for the price, this is the buy trade, so we're gonna set the ask price. This time let's introduce stop loss and take profits value. So before that, let's do the same for a sell trade. Should be sell here and open at the bid price. Okay, now for the stop loss, let's use the gap between support and resistance as our stop loss gap. For example, if this was our support line and the one below here was the resistance line, then we could say if this was a bullish breakout, then we could say the stop loss down here, and if we open a sell trade below this support line, then we could set the stop loss way up here. Since we're doing the opposite, let's define a variable called just within the bullish breakout, we could define a variable called a stop loss difference. Then from the ticks object, we're gonna get the ask price minus this is the entry price, or we could say let's define it as entry price. Then we could say entry price minus the support line, as we are opening a trade above the resistance line. Let's replace this with the entry price. Now the stop loss underscore difference will be used for take profit calculation. Right now, let's just set the stop loss to a support line. Since it's a point on the market, there's no need to convert it or multiply it to points offered by an instrument. This time, let's use a risk-reward ratio. If the stop loss was 100, we want to set the take profit to 200, expecting to gain twice as much as we are risking. So go to the global variables and define the risk-reward ratio. We can set it to true. And for the take profit here, we can say entry price plus stop loss difference, the difference between entry price and the stop loss multiplied to the risk reward ratio. This way, the take profit becomes twice as wide as the stop loss. Do the same but opposite for a sell trade. This time for the stop loss, it should be the resistance line, a value above. When it comes to take profit, we could say the bid price minus stop loss difference times the risk reward ratio. This way it becomes twice as wide as its stop loss. Let's define the entry price here as well. And the stop loss difference equals to Replace the existence of bid with entry price. That's it. We now have a simple breakout trading strategy. If you were to run this directory in the market, down here, create an infinite loop, call the method. Now, when it comes to backtesting this, repeat the same thing we did when backtesting the trend following trading strategy by creating a new file. Call it breakout_strategy backtest. Go to the old file, copy each and everything, and paste in this newly created file. From within this file, you want to import the strategy tester class from the strategy tester 5 framework. After importing the class, just before instantiating the ctrade class, you want to instantiate the strategy tester class. For the tester config, let's go back to the previous file and copy the configs we used earlier on. Tester config, named argument, and assign the new configs. This time we should change the name of the bot. This is breakout strategy. The strategy tester class expects the terminal or the MetaTrader 5 instance, so we assign it the initialized MetaTrader 5 instance. The logging level for debugging purposes, assign logging.debug, which is imported from logging. After that, we should extract the simulated MetaTrader file from the tester object. After obtaining the simulated MetaTrader 5, go ahead and find all the existence of MT5. Press Ctrl F, copy the simulated MT5 variable and replace the existence afterwards. That's it. Lastly, rather than using an infinite loop, we could go to the tester object and call the method run, give it the main function to run. Let's try running this in the strategy tester framework. I'm gonna open the command prompt. Then from there, code Python to run. Okay, I made a mistake when creating the file. Let me change the name. Clear the screen and try this once more. Now, I just realized that we're having too many positions. This is because we are missing the logic control. We're just opening trades. We had the function for checking if a position exists, but we haven't used it. This is why we're ending up with a lot of positions in the backtesting. As you can see, halfway through backtesting progress and we are having 1600 trades. Before opening a trade, we should check if a position of such kind exists. And clear the screen, run. There you go, it took around 26 seconds. Let's head to reports, open this in File Explorer. Then from there you want to open this in a web browser. Great, and as you can see we made huge profits. The total net of 13,000, and it's looking good. Huge profits, and this is partly because we opened each trade at the highest volume. The value of 0.1 is a high lot size to have for each trade, so that could be part of the reason. And so far it seems our simple strategy is doing fine. This is 3 months period. Now let's see what happens if we increase the date range. Let's start from January 2025 up to this year's March, and run this. It's expected to take around 3 minutes. Let's wait for the outcome. After the backtesting is complete, head back to the web browser and refresh the page. And we made even more profits. Let's zoom in. We kept on winning. The total winners were 48, equal to 47%, and we lost 52% of the trades, but the risk reward ratio was doing a great job at offsetting the losses with the profits, because we only needed a few winning trades to make a break-even profit. You can see the graph. Everything is looking great. That's it.